Let's get started. This is the comprehensive guide to tracking protection on Androids. The motivation behind this talk is to kind of help shed a bit of light of what sort of dangers we have using, especially on the Android platform, using apps and navigating through websites, and try to understand a bit of more what are those trackers that we hear about? What can we do about them? What type of them exist, and how can we block them on the Android platform? Things we do at DuckDuckGo in our solutions to prevent this from happening. There's 4 items in the agenda. So we start with what is a tracker, kind of an overview of what trackers are, what type of trackers exist, and a bit more detail of the different types of them. We discuss web versus app trackers, like the difference between seeing trackers on websites and trackers that we can find in apps installed on our device. Kind of trying to show why this is important, why should you care of and be aware of these trackers and try to prevent them, and our solution then to block them for web and also for app trackers. This is kind of a scary number, but this is what we found. Over 90% of your websites and apps that you use or visit are tracking you, and that is something that is important to us, and the numbers should be important as well, because it's not just it is a widespread phenomenon. It's something that happens in a lot of our daily users, websites and apps, and it's important to recognize that and trying to understand what those are dangerous things that happen, and what can we do about them. In essence, the discussion is what really is a tracker in essence. And in the bare low-level description is like a piece of software whose task is to just to gather information about us as individuals while we're using a application or a website. It comes in various forms and from different solutions and companies. We're going to try to give a little more clarity and shed some light on those differences. We have a few types. The first one will be the crash reporters, and those are trackers who specialize in reporting application crashes, like things that you would have in your Android app. You might have third-party SDKs that you use to say when a crash happens in your app, you want to notify that this has happened, so you can have some information about the crash and try to encounter the problem and how can you solve it. So the information collected at the time of the application crash is what the developer will use to correct the bug, and that's usually was being sent. In terms of the analytics, those are more meant to collect data usage and allow the developer to kind of have a better knowledge of the audience, who's using it, and how long is this being used, what pages are they visiting, or how long they have been remaining on a given area of the page. We have profiling trackers, and those are trackers that they want to gather as much information as possible on the application user in order to build a sort of a virtual profile. To this effect, tracker will, for instance, focus on the browsing history, the list of installed applications, and so on. So this kind of helps companies build a profile around you and try to understand what are your usage of what are your interests in terms of browsing, and also in terms of applications. The fourth type, because I'm more dangerous, I would say, with the identification trackers, who are responsible for determining your digital identity, and that might refer as an official identity, or let's say your email address, or can be pseudonyms that you might build with probably your Twitter handles, or some other pseudonym that you might use. And the goal is, for example, to be able to correlate the individual's online and offline activities, so they can use that information to target you with. The most common type of target will be the ads, which they aim to identify the application user, and they want to serve you targeted ads. This is possible and relevant if there is already a profile that has been established. So if the previous type of targets have been successful, then ads will be more relevant if that happened before. And the creator of such tracker is her goal is to monetize your activities and your application and your usage, and making money by the means of advertising. And the last but not least, the sixth, that will be a location tracker. And these are designed to determine the geographical location of your device. And because those third-party SDKs tend to have access to several permissions on your device, they can use the GPS chips, cellular antennas, Wi-Fi networks, even Bluetooth beacons to kind of identify your location and use that for their own purposes. When it comes to how these trackers are being served, we would have two main goals, two main differences. Right? We have bed trackers, things that when you visit the websites, in the web address, you will see some parameters in the URL, and those parameters could give some information about yourself, about your device that you're using, or user agents, or mobile versions, OS versions that you're running. And those are what we commonly refer as third-party trackers, right? Those are mostly permanent in most of the websites you might visit today, and it is important to. My dog just walked in the room. Think of the life. That's okay. If we discuss the other type of tracking, will be app trackers. Those are things that are distributed by companies as an SDK. So if you're an app developer and your interest is to you're building an app, you're not going to go and build from scratch, let's say, a service that allows you to log usage of the application, or let's say crash reporting, as we mentioned earlier, right? Those things already exist. So the typical thing to do would be to use one of these third-party SDKs and already made and just use them and incorporate them into your app, so we can start using them. This, for example, will be an example, right? You will have different apps that would have access to different SDKs, and these SDKs would have access to your location, who you're with, or how long have you been sleeping, or different interests. And these trackers will just send that information out to the different companies who own these trackers, and they will use that for their own purpose. And in the end, it's like, what should you really care about trackers at all? And basically, they have two main goals. One would be to collect all the personal data, and the second one would be to collect your usage data. So third-party companies know that you're going to have the same, let's say, you're going to the same bar every Friday, or even know what school your kids are going to, because that's where you're going to drop them every morning. And knowing that, what websites you visit will create a profile about you. The apps that you have installed will also help to create a profile about you that will tell a story about you as well. And the content of this is targeted advertising, right? If you search for, let's say, holidays in Spain in your phone, and all of a sudden when you're browsing some other application, you see ads that say that there's offers for going on holidays in Spain, it really is because this information that you've been using has been shared, and they can use it to target. They would have data points collected about how long the app has been open, or how many times the app has been opened, and that would give a lot of information to the third party advertiser that will be able to use that against your interest. Same thing goes for things in mobile apps, where usage of what device model you're using, what OS version, even languages. Those are different data points that are collected, and they're all gathered together. They're going to give a very good impression of who you are online, and as your online profile. As an example of information we discovered in the Washington Post, there's a blog about health apps, and sort of information they had. In our members of our privacy team did some research around the health apps in the US, And that's the piece that the Washington Post published about it. And during that investigation, the researchers found that health apps were sending personal information to third-party trackers, and not just any information, just very sensitive information and data. So things like diseases, allergies, treatments, all those specific were being sent, and to not just dozens of ad companies. So I'll leave the link in the slides. So if someone wants to take a read, it's a very interesting read. Kind of scary in terms of understanding how much of your data is being sent around, and you wouldn't expect those apps to be sending it that way. But it was quite of shocking discoveries. So if you have interest in reading this further, please visit the link and you'll see more. In terms of now that we know everything that the dangers that exist and what sort of trackers exist, the first step towards being able to stop them is to knowing what needs to be blocked, and that is not an easy thing. At the lowest level, web and app trackers are kind of the similar thing, and in the end, it's just a request that goes to an IP address, and that URL will have a bunch of parameters, and it will most likely have encrypted data sent as well, and using all that data, able to what we're trying to do is before knowing what to know what to block, is to try to understand, see that traffic, and be able to identify what the tracker is. With that purpose, that goal is a tracker radar, which is a data set. It's not a block list per se, it's a data set about trackers that we automatically generate and maintain. And this is done through continuous scrolling and analysis of such trackers. Everything is open source, so you can go to the link and visit and see that data set for yourself. But it's basically what we use in our internal, the Android app, iOS app extensions. We use that to generate the block list that we use in our products, and we thought that would be important to open source that, so it's visible for everyone to see. On the Android side, it's a bit more complicated, especially because excuse me, especially because it's not as simple. We have a device, and what we did for the solution that we'll talk about later, we got almost 300 apps more apps from Android Rank, and what we did is you install a root certificate in your device, and then you can also use this APK METM, which is a command line that prepares APK files for HTTPS inspection. And what it allows you to do is this, in addition with the root certificate, allows you to just see all the traffic being sent from your device, and we're able to start using those apps, record the traffic, and then look for inputs that we have fed to these apps, so we can understand what sort of information is being sent. And that's what we used to generate a block list that we're using in our Android app today. And in terms of blocking those web trackers, sometimes the sites depend on one of the biggest issues that we found is that sometimes those sites depend on code that is loading from these embedded third-party tracker requests. If we stop those trackers from loading, it can be that sometimes the web just stops working. And one of the solutions that we have as what we call surrogates, and surrogates are small pieces of code that we can use around to work around this the tracker dependent breakage, so we can then still stop those trackers from loading, but still allow the website to run as expected. These surrogates were locally in your device, and they pretend to be a particular third-party tracking script, but actually doesn't do anything. It's an empty thing that doesn't do anything. It just it satisfies the contract with the third-party tracker, so it allows the website to function as expected. this lets us neutralize, part of the website that wouldn't, will be able to track you, and still allowing the website to function as expected. On a specific Android solution, we have DataGo uses WebView as the rendering engine to display to show websites, and what we do is that in the WebView client, which is a very known part of the WebView, what we have is a method that we can override called the should intercept request, and this allows you to return a web resource response that will be the one in charge of. We can use this to then determine if you want to block this request or not. And eventually, what we end up having is as we discussed earlier, we have this surrogate. So if we do know that this request needs a surrogate to function properly, then that's what we will do. We load a surrogate for that specific request and return it. It's a JavaScript function that you see at the end of the resource response. If there isn't a surrogate available for this domain, then what we'll do is just return, in this case, null for the web resource response, and that would tell the web view to just do not do anything and still function properly, but it tells that the request is not going to go through. All the part that we need to take into account are the cookies. So if you're familiar with that, there's two types of cookies. We will have first-party cookies and third-party cookies. When it comes to first-party cookies, the main idea why this was created was to store configuration for the user in terms of navigation preferences or theme preferences for the specific website, and those we are not going to block. And then you have the third-party cookies, which is essentially the same thing as a third-party tracker, where some other services are going to be using cookies in your browser, and that's what we're going to use. For example, so you visit a website which uses a famous ad network, then it will create a third-party cookie based on your consent, and we are familiar with that cookie consent that shows in almost all websites. And then when you visit another website that also uses the same company ad network, they can read that cookie and then identify and acknowledge that you are the same person, and then they will send you an ad, for example, based on the things you saw on the previous sites, which is the example of the holidays that we were describing a bit earlier. In terms of that, Android offers you a very simple API. A cookie manager allows you to set third-party cookies to be accepted or not. This is part of our codes, and the reason why is like this is you can just simply say no to all the third-party cookies. Especially, we have to work around Google authentication. So if you're trying to authenticate on a website with Google, it will come in as a third-party cookie, so we cannot just block it. Otherwise, you wouldn't be able to log in. So we have to go through this and understand if it's a domain that we're supposed to allow for these third-party cookies, allow them for the moment of the event of the login, and then once that login has happened, we can then block third-party cookies again. So in this specific snippet of code, only Google authentication cookies are allowed for the moment of finishing the login purpose. In terms of app tracking protection and blocking app trackers, this is the solution that we've been working on for the last, now it's almost 2 years. It will be the sorry, I'm trying to get the video working there. That would be app tracking protection is a solution that we have currently in closed beta and hopefully in open beta very, very soon, that allows you to see, and of course we take care of the part of blocking those trackers that exist in all the apps that you have installed in your device. That is sort of the UI that we have, and it's a very simple explanation of, in this case we have like 5,000 trackers being blocked across 72 apps in functioning in your app. This is a very high level architecture of how AppTP or app tracking protection works, and what things are working. The main idea of this is we use a VPN service. Is it one of the ways that Android allows you to inspect the traffic happening from your device. And one of the downsides of this is that you can only have a VPN, one VPN connection enabled at a time. So if you're using some external, some remote VPN through other like NordVPN or some other VPN providers, you won't be able to have that and app tracking protection running at the same time. But that is something we are working on to make sure it works. The main idea is the Android will create a tunnel interface between all the apps in your device and the internet. And using that tunnel interface, you're able to identify what apps are making requests, where are those requests going, and then we can operate on those. At the beginning of AppTP, the box between the tunnel interface and AppTP, all that TCP. I have to explain that we do this at TCP IP level. There's an option to do it at the DNS level, but we're not doing that yet. We're doing it as a TCP IP level. At the beginning of all this, we had all these will do manually, so we have the whole file descriptors and all those interactions with the TCP IP connections was doing by us. But lately, we're not using NetGuard, which is a common or famous library for network monitoring. And what basically do is try to extract our dependency from running that TCP IP connections ourselves. We're using NetGuard as an internal layer. That was a native code, so we don't have to. The other thing we need to provide is the native, sorry, the Java layer, the Java interface on our sites, and NetGuard actually has several callbacks that will allow us to identify and respond to different events that we are interested in. And internally, those things has the UDP and TCP sockets that will allow us to identify the traffic there and do whatever we need to do with it. If there's interest in going more deep into this topic, and if there's time, I can take questions, so we can reach out and we can discuss. But it will be time for like 3 hours of talk if we want to go into much detail about RTP. But one of the things that we can do, and that's identifying what are the calling apps that we have. Sorry? There you go. Sorry. Is that better? Okay, sorry. One of the things that we can do is identifying the calling app. And for that, Android gives you, there's a package manager that allows you to find what are the packages that can be found from a UID. This UID is is a unique identifier per app, and it's something that the OS will give you once you install an app. So you install DuckDuckGo, Android will give an identifier to the instance of DuckDuckGo. If you install it and you want to install it again, it will just give and assign a random UID, a new UID. So it's not, for the purpose of this, it's not like a way to identify yourself. It's more like a way to identify the calling application. And for that, what the package manager allows you to do is give you the package name of the UID that you're sending through, and given that package name, you're able to identify, of course, what is the app. It happens sometimes that the package manager doesn't return the UID for that specific app, and for that we just treat it as an unknown application, and we allow to just not do. We then treat that differently when it comes to blocking, but. In the blocking the app tracker itself, this is the call from the native code of the NetGuard layer, and it will give you a call for, can I allow this address to go through? And it will give us the packet, and based on that packet, we're able to identify what is this packet headed to, and based on what is that packet headed, then we are able to use this callback to whether decide to relate through or not, and based on of course on the host name, and we can decide whether this should be blocked or not. This is the implementation of that interface. We're able to just find the hostname in our area cache, and based on that domain, we decide whether we should be blocking that or not. And the the juicy part will be this, which is assuming we have the package ID as shown earlier, we have our block list generated from the information shown before, and that allows us to identify whether that is a first-party tracker or a third-party tracker. And the interesting piece here is we have exception rules. So same as some websites will break if we're blocking some of the trackers, apps will most definitely break if we block certain trackers. The one of the most giant examples will be games. So if you're familiar with some platform games where you have to, between levels, you will be shown a video with an ad, for example. Those videos tend to always contain third-party trackers. So if we were to block that request from the video, the game will come to like a stall state where it just doesn't do anything else. So those are things that we are currently trying to solve and working on. One of the solutions is to add exception rules for specific apps and specific domains that come from those requests, trying to, for now, we have to let them grow unless we find a way to fake those in the form of surrogates that we do with the web trackers, and then use those to make sure that the app keeps working. Happens the same thing with many other apps. We kind of have a video about that later, where you'll see specific apps will go into kind of an unknown state where we don't really know what's going on, and it's because some of those requests, the app expects the request to go through. If the request doesn't, it really is up to the engineers who are building the app to decide what to do with a failed request or a request that times out. Some apps will try to retry aggressively, and you'll have hundreds of thousands of tracking attempts because they're trying to retry the same URL. Sometimes it just doesn't go anymore, and then the app it's unusable. But those are things that we are trying to work on. Once we get this, and we know that it's a third-party tracker, and we don't have to, it isn't part of the exception rules. If we know what app is originating, then we'll block that and ensure that it doesn't go through. That's a part of the unknown app that we had before. It's sometimes some apps that are pre-installed with some devices will not give us what is their package name or the name, so we don't really know what is the app that is making the request. And in those examples, then we just have to unfortunately let them go through. That's a very high-level overview of how the app tracking protection works after using the network layer. And this is sort of how it would look. You'll have the recent activity, and then what we can see here is for every single tracker company that we identify, we have all these signals like the app version, the gender, device network, all those things are things that we are known to, those companies are known to collect. All this information comes from all the work done earlier with the privacy team, going app by app, monitoring the traffic and understanding what are the messages that are being sent, what are the requests and the parameters being sent with those in those bodies. And with that, we can then say per app, per of these companies, and for all those domains, what are the different signals that are known to collect. And it's kind of a way to highlight the importance of the work being done here and understanding how dangerous it is that some companies are able to understand things about you that you were prefer to keep to yourself, or even just simply with your data, you should be able to do whatever you want with them. And that was the part of the app breakers that we was mentioning earlier. So one of the things that can happen is some apps will just break at some points. So in app tracking protection, we have this screen that allows you to just turn protection, disable protection for a specific app. and hopefully you will send a report explaining what is it, so we then can collect that information and try to find out what is a specific domain that we that give us the issue, and then to work around that. And that's the benefits of having this closed beta now, that we're able to know more about the usages. And all this is open source, of course. The code for app tracking protection, all of it, plus all the code for the browser, both features are part of the main browser app flag that goes. So if you're curious and you want to understand a bit more, or you want to just to read more, please feel free to go and look at the code, write us some issues or some feedback if you're interested. But everything that we shared here today is all there. And I want to thank everyone there. I hope there's someone in the room. It's very weird to have a call, to have a give a talk online when you don't know someone else besides Stefan on the call. So I hope it wasn't too bad being there. And hopefully I can join you all next year in person and enjoy the conference. I think there's time for questions. I don't know if there's a way to make those through, but thank you.